How do you convert from grams to moles? Let's look at a real-life chemical equation. There it is. This is the chemical equation for the combustion of butane with oxygen to form carbon dioxide and water. We will be converting grams of butane to moles of butane as we explore this reaction. Have you ever heard of butane? Butane's chemical formula is C4H10. Here is a molecular model of butane. Do you see the 4 black spheres? They represent butane's 4 carbon atoms. Butane has a carbon backbone of 4 carbon atoms bonded together. Do you see the 10 white spheres? They represent butane's 10 hydrogen atoms, which surround the carbon atoms. But that's just a model of butane. Just so happens that I have a tank filled with butane right here. Now, chemistry isn't much fun if you don't do the reaction. So here goes, the reaction of butane with oxygen. Chemistry's great. And believe it or not, we converted the butane and oxygen into carbon dioxide and water. Now, on with your question. How do we convert from grams of butane to moles of butane? This tank has 952 grams of liquid butane in it. That's our starting gram amount for our problem. The question I have for you is, how many moles of butane are in this tank? The first thing we need is the conversion from grams to moles for butane. Do you remember the name of the term that tells you how many grams there are in 1 mole of a substance? It's called the molar mass. Let's look at that name, molar mass. Do you see that the word mass and mole are in the name? Literally, the name means the mass we have if we have 1 mole. So how do we find the molar mass of butane? Because we need it to convert from grams to moles. All we do is add up the individual atomic mass numbers of the atoms that make up butane, C4H10. The periodic table tells me that carbon equals 12.01 grams per mole, and hydrogen equals 1.008 grams per mole. For simplicity in today's discussion, we will round carbon from 12.01 to 12, and hydrogen from 1.008 to 1. When you do the practice problems at the end of this video or in your chemistry class, please don't round atomic mass numbers unless your instructor says it's okay. My butane formula has 4 carbons, so I take the mass of the carbon from the periodic table, 12, and multiply it by 4 carbons for a total mass of 48. That means that the 4 carbon atoms in the formula for butane contribute 48 grams to the mass of 1 mole of butane. My butane also has 10 hydrogens, so I take the mass of hydrogen from the periodic table, 1, and multiply it by 10 hydrogens for a total mass of 10. That means that the 10 hydrogen atoms in the formula for butane contribute 10 grams to the mass of 1 mole of butane. Then I add the two together. 48 from the 4 carbon atoms in the formula plus 10 from the 10 hydrogens in the formula equals 58 grams per mole of butane. This is the molar mass of butane, 58 grams per mole. In other words, if I have 58 grams of butane, then I have 1 mole of butane molecules. Let's use the molar mass of butane to calculate how many moles of butane are in my tank, which has 952 grams of liquid butane in it. I need to use the molar mass, but how? Would you multiply or divide 952 grams by the molar mass? This is where some people guess and end up having difficulty with the math. I don't want you to guess. Sure, I'll tell you right now that you should divide 952 by the molar mass of butane, which is 58 grams per mole. But how did I know to do that? What I really want to do is show you a great method so you never have to guess whether you need to multiply or divide. Sure, it takes more effort, but the benefit is you will become very confident in your chemistry calculations. Here's what you do. You take what you are starting with, in this case 952 grams, and express it as a fraction. Now 952 written as a fraction is just 952 over 1. That's not tough. Then you make sure to write the units. Remember, we have 952 grams of butane. Then you make a cross. Easy so far. The cross gives you a place for your molar mass to be written as a fraction and keeps everything neat. You write the molar mass so that the 58 gram part is on the bottom and the 1 mole part is on the top. Do you see that I've written the molar mass? It's written such that we would say 1 mole of butane per 58 grams of butane. There's nothing wrong with the molar mass being written like that. It's a true statement. Now look closely. What do you notice about the units in what I've written thus far? Look specifically at the gram units. Do you see that the grams from my 952 grams of butane are on the top and my 58 grams are on the bottom? When we have the same units on the top and bottom, we can cancel the units. What units are left? That's right, moles are left. This method tells us that we will get an answer with units of moles, which is what we want since we are converting from grams to moles. So what is the math telling us to do? We multiply numbers next to each other, we divide numbers underneath each other. So this method is telling us to multiply 952 grams by 1 and then divide by 58. Let's see what we get. The answer is 16.4 moles of butane, which we round to 16 moles using significant figure rounding rules. So 952 grams of butane equals 16 moles of butane. Now, before we say that we are done with this problem, we should always ask ourselves, does this answer make sense? Remember that this tank has 952 grams of butane in it. Also remember that we have a mole of butane for every 58 grams. So it makes sense that we'd have 16 moles of butane. Checking to make sure our answer makes sense is an important step. Now let's see what would have happened if we had done the problem with the molar mass flipped. This would have been bad. Do you see that with the molar mass flipped, 58 grams of butane over 1 mole, we don't have the grams canceling each other out. We have grams on the top in each fraction. So if we did the math as suggested in this setup, we would have an answer with units of grams squared over moles. What is that? It's nonsense. When we set up our problem with this method, if we don't have the correct units in our answer, after canceling units, we know that the problem has been set up incorrectly. This method allows us to be aware of when we have set up a problem incorrectly. By the way, this method of using fractions and canceling units is called dimensional analysis. By practicing with it now, you'll have a much easier time with more complex calculations later, as you continue to become a more powerful chemist. I'll leave you with some worked out problems. You try the problem, then pause the screen before looking at the answer. If you can do these problems, then you shouldn't have any issues converting grams into moles.